The International Space Station, a marvel of modern engineering, a symbol of international collaboration and unity. It orbits Earth at an astonishing speed of 17,500 miles per hour, a breathtaking 250 miles above us in the vastness of space. This incredible laboratory is home to astronauts from different countries working together. They live and work in microgravity, conducting experiments and observing Earth from above. The ISS is a testament to human ingenuity, pushing the boundaries of space exploration. But what if someone jumped from this incredible structure into the void? Let's explore the fascinating science behind a fall from space. Space is an unforgiving environment, devoid of air to breathe, lacking the atmospheric pressure we are used to on Earth. Temperatures can fluctuate wildly, from extreme heat to bone-chilling cold. Astronauts on the ISS are protected by their suits and by the station itself. But venturing outside, even for a short time, is incredibly dangerous. Exposure to the vacuum of space can be fatal very quickly. Without the protection of the ISS, a human body would be exposed to the harsh realities of space, making survival impossible. We know what it feels like to fall on Earth, the sensation of gravity pulling us down. It's a force we experience every day, whether we're jumping off a diving board, tripping over a rock, or simply dropping a pen. Gravity is a constant companion, always reminding us of its presence. But in orbit, it's different. Objects, including the ISS and everything on it, are in a constant state of free fall. This means they are falling towards Earth but moving forward so fast that they keep missing it. This creates a unique environment where everything appears to float, creating the illusion of zero gravity. Imagine you're on a roller coaster at the top of the highest drop, that feeling of weightlessness. It's a brief moment where gravity seems to take a back seat and you feel like you're floating. This sensation is thrilling and a bit disorienting, but it's fleeting. That's similar to what astronauts experience all the time on the ISS. However, for them, this feeling isn't just a momentary thrill. It's a constant state. They float around, conducting experiments, eating and sleeping, all while experiencing this continuous free fall. So if you jumped from the station, you wouldn't feel like you were falling, not initially. Instead, you'd feel like you were simply drifting away, as if you were gently pushed by an invisible hand. This is because both you and the station are moving at the same speed. You'd simply drift away from the station, still bound to Earth's gravitational pull. Over time, you'd start to notice the pull of gravity more as you moved further away. But initially, it would feel like a serene, almost peaceful drift into the vastness of space, a stark contrast to the sensation of falling on Earth. A dance with gravity. Here's where physics gets interesting. In the vast expanse of space, the rules of gravity still apply, but they manifest in fascinating ways. Imagine floating in the International Space Station, surrounded by the infinite void. Even though you'd feel weightless, you wouldn't escape Earth's gravity. This sensation of weightlessness is due to free fall, as both you and the station are falling towards Earth at the same rate. It's weaker in orbit, but still present. The gravitational pull keeps the space station and everything in it tethered to Earth, albeit loosely. Your initial velocity from the jump and the station's own orbital speed would send you into a slightly different orbit. This delicate balance of forces creates a unique dance with gravity. You'd circle the Earth like a satellite, but without the controlled trajectory. Unlike satellites, which have precise paths, your orbit would be more erratic. Over time, Earth's gravity would do its work, pulling you slowly but surely back towards the planet. This gradual pull is a constant reminder of the invisible force that governs our universe. This process of orbital decay could take days, even weeks, depending on your initial trajectory. The closer you are to Earth, the faster you'll descend. It's a slow, inevitable journey back to where it all began. The perils of re-entry. As you descend closer to Earth, the atmosphere gets denser. This is where things get dangerous, really dangerous. Imagine a spacecraft returning from orbit. It encounters friction from the air molecules. This generates immense heat, thousands of degrees. The same would happen to you. Without a protective heat shield, your body would burn upon re-entry. Not a pleasant way to go. And let's not forget about oxygen, or the lack thereof. At those altitudes, you'd suffocate long before you hit the ground. No parachute? No problem? Let's entertain a hypothetical for a moment. You magically have a spacesuit. It can withstand re-entry. You survive the fiery descent. What then? You'd still be plummeting towards Earth at terminal velocity, which is about 120 miles per hour. Without a parachute, that's like hitting concrete at highway speeds. Survival? Highly unlikely. The human body is fragile, space is unforgiving, and the physics of falling from orbit? Well, they don't leave much room for error. Section 7. The Final Frontier's Grip. So, what have we learned? Jumping from the ISS is a bad idea. The International Space Station orbits Earth at an altitude of approximately 400 kilometers, traveling at a speed of about 28,000 kilometers per hour. This means that any attempt to jump from the ISS would not only be futile, but also incredibly dangerous. A very bad idea. The vacuum of space, the heat of re-entry, the impact with the ground. The vacuum of space is a harsh environment where there is no air to breathe, and temperatures can swing from extreme heat to extreme cold. Re-entering Earth's atmosphere would subject the body to intense heat, enough to incinerate most materials. And even if one somehow survived these perils, the final impact with the ground would be catastrophic. None of it is conducive to human survival. The final frontier is awe-inspiring, but it's also incredibly dangerous. Space is a realm that commands respect. The beauty of the stars, the vastness of the cosmos, and the delicate balance of our planet seen from above are all reminders of how small and fragile we are in the grand scheme of the universe. We explore it, we study it, but we must always respect its power and the laws of physics that govern it. Scientists and astronauts dedicate their lives to understanding the mysteries of space, conducting experiments that could one day unlock the secrets of the universe. Yet they do so with a profound respect for the dangers that space presents. For now, let's leave the space jumps to the professionals. These individuals undergo rigorous training, preparing for every possible scenario they might encounter in space. Their expertise and preparation are what keep them safe in such an unforgiving environment. Those with the training, the equipment, and the understanding to navigate this extraordinary and unforgiving realm. The final frontier is not a place for the unprepared. It requires a combination of advanced technology, extensive knowledge, and unwavering courage to explore and survive in space. So, let's admire the bravery and skill of those who venture into the cosmos. And remember to respect the immense power and mystery of the universe.